Hello and welcome to another video of MADCUBA. In this tutorial we are going to start explaining the spectral line identification and modeling, or SLIM. Briefly, this tool will allow us to search for spectral lines, simulate and fit them to observational data. In this example we are going to search for one molecule, acetonitrile, and perform an autofit. In order to do so, we first have to open the fit file with the data we want to analyze. Once we have it, and we see it in the spectral container, it is compulsory to select it before we open the SLIM tool. Now we can go to the main menu and click on SLIM. The first display that shows up is known as SLIM database. The primary function of this window is to search for molecules of different molecular catalogs. They can be seen by pressing the catalog button. As we can see, a few different catalogs such as GPL and CDMS are available to search for. The molecules can be found either by scrolling down in its catalog or by entering the chemical formula in the Select Molecules box. We see that in our example, many different possibilities are prompted automatically inside the box, according to the CDMS distinct entries that matches our inquiry. Once we find it, we can search the spectral line within our data either by selecting the molecule and clicking the search button, or by entering the molecule in the empty box with the right arrow button and clicking again the search button. When this is pressed, three new windows will be created: SimFit, Information MADCUBA, and SLIM Table. If we switch to the SimFit window, we can see that the molecule we have seek is now in the molecular parameters box. By clicking it, a plot showing the observational data in black and the simulated data in red will pop up. For the proper visualization of the transitions we have found, we can change the range in which the data is shown by entering the value we desire and pressing enter, and whether we desire to have labels on them, which is changed in the lines button. In this case we have decided to erase them. Now note that the simulated physical parameters are shown in the table, and that can be changed as we please with the parameters sliders down below. Be aware that we can change the range in which the values are shown by clicking the parameters next to the sliders. So suppose we desire to show more values in the column density, we can just type it, and then we press enter. So, in the case that using the sliders is not comfortable, we can always type the value we desire. As an example, I am changing the excitation temperature value down to 50 Kelvin. For this, we go to the excitation temperature value, and then we double click on it, and we enter the value of 50 and press enter. This action must always be followed by pressing the simulate button to see how the change looks like. Be aware that the best approach to perform an autofit is to find the initial set of parameters that we think are closer to the answer. In some cases, it would be extremely helpful to let some parameters fixed. This action is done by clicking the checkbox next to the value we decided not to change during the procedure. In our example, we have only set one parameter fixed, the source size, while the other four are set for free. Nevertheless, we can clearly see how our initial guess of parameters are far from the observational data. So, in order to improve this, we need to make the lines narrower. Now we can proceed on the calculation by pressing the AutoFit button. Provided that the calculation converges, the software will prompt some information about it. In turn, if the fit is successful, the entry of the molecule in the molecular parameters box will become red. This is a simple example, but in some cases it will be extremely useful to make the initial guess from a rotational diagram, which is also supported in SLIM. We can access it by right-clicking the molecule we desire. The details on these concrete tools will be made in the next videos. Finally, in case you are interested, you will find below or in the web page additional documentation on this software and its different tools. Thanks for watching.